S3 bucket to save the results of the query execution. Interesting. What the hell is a working group? Output of what? Serverless interactive analytics service built on top of open source frameworks supporting open table and file formats. Athena provides a simplified, flexible way to analyze petabytes of data where it lives. Analyze data or build applications from Amazon. Simple storage service, data lake, and 30 data sources, including on-premises data sources or cloud. Trino and Presto engines and Apache Spark frameworks. Submit a single query. Use this as our source of data. Now we'll define a name, Athena TF. In this file, we're going to create an Athena working group, DB table, and our query. For our AWS glue catalog table, we have a catalog database, a glue catalog table, which we already have to set up the schema for the S3 persistence, and then they have a working group. Why is this called output location if it is used for the input? Location in Amazon where your query results are stored. See, that doesn't seem like what we want. Sounds different. Seems different than this, because this is AWS log bucket, which is this. Let's define S3 bucket in the which we will use as a source of data. I'm still not clear on that, but that's okay. So they're just tacking my data onto it. And then here they're tacking output onto it. Need some better music. All right, what do we got? Named query. Athena working group. Definition in Terraform to automate the behavior, assuming that you already have S3 bucket configured. Assume we have a bucket which is referred by AWS as 3bucket.myservice.bucket, and the in the bucket that we want to integrate with Athena is stored in the directory myService.myData. It's also assumed that the data stored there is similar to the following. It is simplification of a real scenario which stored statistics about processing and import of CSV files. First thing I had to do was create the Athena database. AWS glue my database. My service, what? Why is it called my database? However, that we had to use glue to define the database. After that, all I had to do was create the table definition. Why does it say glue my database again? That shouldn't say that. After that, all I had to do was create table definition, in particular the table name, my table, the database name, through the reference to the resources previously where they got the data. From S3 buckets, format and serialization information, finally, and data structure to be able to be queried. Okay, so the glue database, let's go. Kinesis metric event consumer. We have a glue, AWS glue catalog database. Catalog table. We have our Kinesis metric event consumer. Okay, well, it's very different.
Can't get a game. Shit, I got some change on me. Look into my eyes, moving it right. I might just pay the fee. She's cash bleed. She got a way of making the block free. Cash bleed. Can't get a game. Shit, I got some change on me. Look into my eyes, moving it right. I might just pay the fee. She's cash bleed.
Seems like this is the same thing.
Cash bleed.
Yeah, dude. Like, I think that post is just garbage.
Can't get a game. Shit, I got some change on me. Look into my eyes, moving it right. I might just pay the fee. She's cash bleed. She got a way.
Some random number from the Netherlands. We're gonna have to figure out. Input format. Let's try some deep focus. Database glue catalog table. This is storage descriptor. Optional configuration block for information about the physical storage of this table. For more information, refer to the glue developer guide. I don't think that's what I want. Maybe it is. I don't know. Location string, not more than 2056 bytes long, matching the URI address multi-line string for physical location of the table. By default, this takes the form of the warehouse location, followed by the database location in the warehouse, followed by the table name. Format string, not more than 128 bytes long, matching single line string pattern. Input format sequence file input. I mentioned I hate AWS. I just hate it. All right, let's. Let me log in. Maybe we'll see. Dude, this is killing me too. We need some better tunes. Point to your data source. Register and select any data source. Start querying. Athena's query editor lets you author and run SQL statements to query your data. Analyze the results. Query results are delivered within seconds. Use query editor to analyze data on S3 on premises. Need to set up a query result location. Okay. Back to this. So let's say we declare a database, provides an Athena database. We got to give it a bucket. Give it a name. Name of S3 bucket to save the results of the query execution. Name of the database to create. One or more work groups have been upgraded to Athena Engine version 3. To see the work groups that have been upgraded, use work group list page. Do we have any? Before you run your first query, you need to set up a query result location in Amazon S3. Okay. Athena now supports type ahead code suggestions to speed up SQL query. Okay, where do I want this to live? Do I want it to be part of the Kinesis ingest? I mean, the storing of the Parquet files is part of it, so it seems like I probably want to make this part of it as well. Metric events raw metric events query results. Project prefix, environment, Kinesis stream metric events. No. Do I want this? Events query results. This music. Oh, I tweaked my neck last night. Alright, let's go to moods. What does angry mood music sound like? Stupid EKS node group. The heck? Why am I not hearing this? Why is the audio not working? What the crap? Awesome on so many levels. Alright, well, no audio right now for some reason on that front. Other audio works fine. Who knows? Safari's just crap, maybe? I don't know. I guess we can again.
Imagine the power of being able to explore
Amazon Athena, it is pressed 11. If I basically is database, Athena is also in the same region, so no, it has not to upload the data on itself. The next thing is the pricing. Going with pricing, we don't have to upload the query and how to work with data in our Amazon Athena. Now, Amazon Athena is a query editor, as our Redshift cluster is a data warehouse. How they are different? In Redshift, we upload the data, but in Amazon Athena, we don't have to upload the data. If our data is available somewhere, we can directly query it. So in this hands-on, we will be learning that from how can we do the same thing with our S3. Let's say if we have a S3 bucket and we have our data inside that, how can we query that data? So for that, we will be using this data, which is our movie database. Now here are three columns: so movie ID, title and genre. So for the same, we have to go to our Amazon Athena. Inside query editor, we will be creating a table. But before that, let's know where to go, from where we can find Athena. So for that, click on to global search box and write Amazon Athena, and you can see Athena is here. Click on it and it will open the console for you. Now once the console is open, you can see that we have data source, that is inside which database we want to keep the table. Now here database is showing default, but if we want, we can create more databases. And how we can create database? So just write create database my data, and the database will be created as soon as I click on run, and query ran complete successfully. And now if I click on this, you can see my data is available, and now we are inside my data database. Now the next thing is creating a table. So for that, we can create from query editor as well as from the console. So we will go with console, and I will even show you the code for the same. So we have to create a table from data source S3 bucket, because our data will be uploaded in S3 bucket. So let's first upload the data in S3 bucket. So for that, we will be removing this first column, which is movie ID, title and genre. So just delete it and save. So now we have deleted this column. Now we will be exploring further why we deleted those columns. So now click on create, and before that, let's create our S3 bucket. So click on create bucket. After going to S3, let's say my Athena bucket, and let's give a name so that it can be identified and it can't be like similar to others. So let's say version 1.0, because for S3 bucket we should give always a unique name. So now it will be in US East 1A, and our Athena is also in the same region, so no need to worry about it. And create bucket. Now our bucket has been created, so let's see my, and here it is. So let's open and upload, add files, but I want to be adding a file. Let's add a folder. Upload, sorry, not upload, cancel. Let's create a folder first, and my folder will be, let's say, movie data. This will be my folder, and inside this folder I will be uploading one of the files. Upload, add files, and here is my movies. Open and upload. Now it has been uploaded, and I will even copy its destination. Now where we will use this destination? go to Athena and let's create our table. So S3 bucket, table name, let's say movies, and you will notice one thing, even though I am giving the table name in capital, it will change when my table will be created. So choose an existing database. Inside my data I will be creating, and here paste the path, the destination where our data is available, and table type, file format. Inside file format, select C.
Oh, come on.
Because the data which we have uploaded is in CSV format, and here you can go with any option, just leave it at default. Now the next thing is we don't want any encryption, so we will not go with that. And after that we have column details. So how can we create column? We can just write like movie ID, select column type as integer, or the next thing is what I can do, I can just go to bulk add columns and movie ID, integer type. The next thing is, let's say, title of type string. The next thing is genre of type string. And if I click on add now, you will see that all the three have been created, which means that I can create all the columns together as well as single column at a time. Now we don't want any partitioning and we don't want any bucketing, and here at the end we will be able to see the command for the same. Like we are creating this table inside my data, the table name is movies and movie ID is integer, title string, genre string, which means these are the fields of my table. And after that the format which we saw here, this is my format, simple survey. You can see lazy simple survey. Now file type, you can see at the end CSV, which we uploaded at the top. Now if I click on create table, the table will be created but the data will not be loaded in the table. Now how I can say that the data is not loaded? Because this table will not like contain anything. It will just contain these three things, the columns, and the rows will be available inside my S3 itself. Now if let's say I want to see it, I can just double click and here go to review table, and it has been ran, and you can see that all are available. Now if I just remove this limit and run, now you can see that not only one, there are multiple columns available, like 100 rows in this one, and the further data will be available here. Next, here the further data will be available. Now this is the benefit of going with Athena, that it will show us all the data. Now let's say if I want to create another table, yeah, I can do that as well in the same bucket. This thing is, let's say all the three have been created, and here at fields of my table, you can see loaded at data is not loaded because this table will not like contain anything. It will just contain these three things, the columns, and the rows will be available inside my S3 itself. Now if let's say I want to see it, I can just double click and here go to review table, and it has been ran, and you can see that all are available. Now if I just remove this limit and run, now you can see that not only one, there are multiple columns available, like 100 rows in this one, and the further data will be available here. Next, here the further data will be available. Now this is the benefit of going with Athena, that it will show us all the data. Now let's say if I want to create another table, yeah, I can do that as well in the same bucket. So let's
There's an Athena database. Is there an Athena table? Terraform. Maybe that's Athena table. that UI? Is that doing like another glue table, catalog table behind the scenes? This just creates some sort of grouping mechanism, it seems like, but it also has this output. Maybe it's the working group, maybe I just don't understand working groups.
Close this, create one more folder. Let's create folder online retail. I will use another
Terraform, set up Athena or S3. Not helpful. Pretty nice 3 bucket, which is the Athena workspace, which gets the work group bucket, whatever the hell that is. Yes, S3 bucket lifecycle configuration. We're doing this to set up expirations. Public access block Athena workspace. This is weird. Athena work group. There's the database. The thing I'm missing is, like, how are these things connected? Like, how is this AWS Athena work group it's connected to the query? Okay, so the only place the work group is connected is through the query, through a named query. And the database is set up through a named query. I guess. The other thing that's confusing is like understanding the thing that's just confusing is AWS Athena data catalog. What in the world is that? More information about Athena and Athena data catalogs can be interactive query service. Yeah, I know what it is. I want to know what these various pieces are. Database, okay. In Athena, catalogs, databases, and tables are containers for the metadata definitions that define the schema for underlying source data. Athena uses the following terms to refer to hierarchies of data objects. A data source is a group of databases. A database is a group of tables, and a table is data organized as a group of rows or columns. Sometimes these objects also refer to with alternate but equivalent names, such as the following. A data source is sometimes referred to as a catalog. A database is sometimes referred to as a schema. Okay. Following example query in the Athena console uses the AWS data catalog data source the default database and the sum table. Yeah. For each data set, a table needs to exist in Athena. The metadata in the table tells Athena where the data is located in S3 and specifies the structure of the data, for example, column names, data types, blah, blah, blah. Databases are logical grouping of tables and also hold only metadata and schema information for a dataset. For each dataset that you would like to query, Athena must have an underlying table it will use for obtaining the returning query results. Therefore, before querying data, a table must be registered in Athena. The registration occurs when you either create tables automatically or manually. You create table automatically using an AWS glue crawler. Maybe this glue creates a table, it registers it in its own AWS glue data catalog. Regardless of how tables are created, the table creation process registers the data set with Athena. This registration occurs in the AWS glue table. Registration occurs in AWS Glue data catalog and enables Athena to run queries on the data. Athena query editor, this catalog or the data source is referred to with the label AWS catalog. After you create the table, you use blah. Okay, but. So we have a catalog, a data catalog, and the data catalog has a name, description, a type, which can be of lambda, Hive-based data catalog, glue-based data catalog, lambda-based data catalog. I'm not sure I understand what a Athena data catalog is. Contains information about a data catalog in an AWS account. Data catalogs are listed as data sources on the data sources page under the data source name. Okay. So if a data catalog is a data source, what kind of parameters do we have for it? Maybe glue? Okay. So it needs a name. Needs a type, key value pairs that specify lambda function or functions to use for the data catalog. The mapping used depends on the catalog. Description, tags. Okay, so where do work groups fit into this? So we have a data source, database, and a table. So we got data sources, supposedly. I don't know how we specify that it's S3. ADBS Athena data catalog for Parquet files in S3. Oh, what a pain in the butt. Okay. Query data stored in different locations and formats in dataset. This dataset might be in CSV, JSON, Avro, Parquet, or some other format. Tables and databases you work in Athena to run queries are based on metadata. Metadata is data about the underlying data in the dataset. However, that metadata describes your dataset is called schema. For example, a table name, the column names in the table, and the data types of each column are the schema saved as metadata that describe an underlying dataset in Athena. We call a system for organizing metadata a data catalog or a metastore. Combination of data set and data catalog that describe it as called a data source. So the combination of a data set and a data catalog. It's the combination of like the S3 bucket and pathing information combined with the catalog is called a data source. The relationship of the metadata to an underlying data set depends on the type of data source that you work with. Relational data. Natively supports ADBS Glue data catalog. The ADBS Glue data catalog is a data catalog built on top of the other data sets. And data sources such as S3, Redshift, and you can also connect Athena to other data sources by using a variety of connectors. Really now, really. So if we go look at the UI, what's interesting, well, it's got one primary work group, and that's got this ADBS data catalog, data source, and that has a raw metric events glue catalog database, which is not something we've created for Athena. That specifically, that is the glue database that we created for Firehose to have a schema, have a database and have a schema. So that's a database, but then the data source, this is where we would have to create a table. And this is where I do not know. Would we want to create a table with SQL? No. We'd want S3 bucket data. And the other option is this AWS glue crawler. Choose to access an existing database or create a new database in order to create a new table. Athena stores the table schema in the AWS Glue data catalog. But that's the part that I don't understand. How do I create one of these? How do I create one of those? Tell me now. Python not that helpful, okay. This is useful, okay. So we have a work group, which is some high level concept. Need to understand how this glue integration works. Athena can connect to your data store in AWS S3 using the AWS Glue data catalog to store metadata such as table and column names. After the connection is made, your databases, tables, and views appear in Athena's query editor. Your databases, tables, and views appear. To define schema information for AWS Glue to use, you create an AWS Glue crawler to retrieve information automatically. Or you can manually add a table and enter the schema information. What is this crawling? To create a crawler in AWS Glue starting from Athena console. On AWS Glue console, add crawler. What is it crawling? Following procedure shows you how to use Athena console to add a table using the create table from S3 bucket data. Help discover the schema for data sets and register them as tables in the AWS Glue data catalog. The crawlers go through your data and determine the schema. See, we shouldn't need that. That's what my assumption was, but we shouldn't need that. It's a well-structured, well-formed schema. So we shouldn't need that. What I'm trying to figure out is if we can actually just use the existing schema that we defined as a glue catalog. Can use Athena's cross-account AWS glue catalog feature to register a AWS glue catalog. See, this is where it's like, I think the missing piece I'm having right now is, missing piece of the puzzle is this create table thing. What the hell does that actually do in Terraform land? How do I go about creating a table from an S3 bucket? Create Athena table from S3 bucket in Terraform AWS create Athena table from S3 bucket. It's not database. Did I look at that? Glue data catalog to store metadata. That's great. That's great. All right. I'm resorting. I'm sick of Googling. Interactive queries, yeah. Work groups in Athena are used to segregate query execution and data access for teams and applications, allowing for better management of resources and access controls within an organization. Each work group can be configured with its own set of data access policies, blah, 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 blah. When a query is executed in Athena, it runs within the context of the work group. Users and applications can specify a work group when submitting a query. Provide a way to manage access controls, costs, and priorities. S. For querying data sets in S3, making it a useful tool for organization to manage their Athena usage effectively. Okay. So, cool. So, standing AWS Athena. Okay, let's make something here so we can understand what the hell things are. Let's just okay. Let's say this is Athena work group. Okay. And this translate to AWS Athena work group in Terraform. And this is simply a grouping mechanism to allow separate firms. Okay, cool. So we have this Athena work group. What's our next concept that we need to understand? Okay. Somehow there's a table, but we need to understand what the hell that translates to. There's a database. ChatGPT to the rescue. What is an AWS Athena database? It's a logical namespace within Athena that contains tables. These databases and tables allow you to organize and manage your data. They work in conjunction with S3, where the actual data is stored in various formats such as blah blah blah. When you create a table in Athena database, you define a schema that maps to the data in S3. This schema includes definitions of columns and data types, which Athena uses to parse the data files during the queries. Athena databases are a part of Athena's integration with AWS Glue Data Catalog, which serves as a central metadata repository for various AWS services. The Glue Data Catalog stores information about your data sources, making it easier to set up, manage, and query your data sets across these things. An AWS Athena database is a collection of tables. Okay. And that maps to what am I thinking? Where are we? There's too many things. That maps to this database, but the database has a bucket for the results of the query, and that's it. Name and access control stuff. Properties, key map, custom metadata properties for depth. So properties could have something more in it. No, it doesn't look. I don't think. Okay, so we have the Athena database. Okay. Logical namespace within Athena that contains tables. These databases and tables allow you to organize and manage your data. They work in conjunction with Amazon S3, where the actual data is stored in blah or Parquet. When you create a table in Athena database, you define a schema that maps to the data in S3. This schema includes definitions of columns and data types, which Athena uses to parse the data files during query. Athena databases are part of Athena's integration with the AWS Glue Data Catalog, which serves as a central metadata repository for various AWS services. The Glue Data Catalog stores information about your data sources, making it easy to set up, manage, and query your data sets across AWS. Okay. So we have so we have working group, we have database, we have prepared statements and named queries. Athena named query and Athena prepared statement. Okay. I'm pretty sure I know what these are, but what I don't know, is I guess we'll just go look at these two. Athena and this. We need AWS Athena data catalog in there. Okay. Prepared statement. There's a work group, a database, and a prepared statement. TF test. Select star from blah, where blah, part of this working group. Okay, that just seems like what I expected. Okay, and named query is going to be similar. Sure, they got some different stuff here. They got a named query. Part of this working group, part of this database, and then here's the query. And okay, not super helpful. Those are what I think they are. And then we have the other piece of the puzzle, which is this guy, which is an AWS Athena data catalog, which is a piece of the puzzle I don't quite understand. We have a name, a type, which is glue, and then we have parameters. And the example for the glue is give it a parameter with a catalog ID. Which is, I assume, this is where I'm not sure. What is the purpose of an AWS Athena data catalog? Relation to Amazon Athena is glue and data management across it. The data catalog acts as central repository for metadata about your data stored across AWS services. This includes information about your databases, tables, columns, as well as data locations, formats used, central facilitate, blah, blah. Stores and manages schemas related to your data. It does not do all of these things using Athena. The data catalog provides the necessary schema information enabling. What would... Show me an example of using Terraform to set up an Athena data source for S3 Parquet files. There is no... This doesn't exist. ChatGPT, you're a liar. It's not directly available in Terraform's AWS provider as of my last update. Instead, you typically use AWS Athena database resource along with raw SQL in the AWS Athena named query resource to create tables. The AWS Athena table and its properties are provided here to illustrate what the configuration might look like conceptually. You would replace the AWS Athena table resource with an appropriate SQL create table statement inside an AWS Athena named query resource that creates the table schema, referencing your Parquet data in S3. Ensure you replace the placeholders and example values with those relevant to your thing. So you're telling me there isn't a way. This is just a giant missing piece of the puzzle. And maybe that's why I've had so much confusion. But what is it saying? How do I use this? How does doing a named query help? Like, it doesn't automatically run that query. It just exposes it as a named query. Example of using AWS Athena named query to create a table for an Athena table for Parquet files in S3. Where's the schema? That's not creating a parquet table. Create parquet table. Okay. After creating the table, you'll need to load partitions into Athena. This can be done using misc repair table your table name command, which can also be executed as Athena named query in Terraform. However, for large data sets with many partitions, consider using more efficient partition management strategies such as adding partitions manually or using AWS glue crawlers. Here's how you could define a named query for loading partitions. The setup assumes you have existing Athena database and necessary IAM permissions for Athena to access your S3 bucket. Just the column definitions and data types in the create external blah. Interesting. Okay. So let's go back here. So we created our S3 somewhere. Right here we created our S3, okay. Let's also create we're gonna have a resource, which is going to be our Athena AWS work group. AWS Athena work group. Which we're gonna call raw metric events group. query results dot bucket. Encryption shouldn't have to. This is part of result configuration. Part of configuration. Publish CloudWatch metrics. I don't know what that. Boolean whether the settings for the workgroup override client-side settings. So there's highlighting. Okay. So we have this AWS Athena work group. Then going to have an AWS Athena database, which we will call raw metrics events Athena DB. And that is this is what I don't understand. What is the distinction between these two? Why does this? So we're going to have a database, which will be name, and then this is going to be raw metric events. Let's say that's the name of the database. We're going to have raw metric events working group, work group. But then, no, this is the strange part, is we're then going to also have a bucket. And the bucket again is the output. It's going to be AWS S3 bucket dot raw metric event query results dot ID. I guess required the name of the S3 bucket to save the results of the query execution. But what the hell was this output location? That output location is part of this optional configuration block for resulting settings. Optional location in S3 where your query results are stored, such as blah. Yeah, so this sounds like it's exactly the same thing. Which one trumps? We will find out, I guess. Okay, so then we're going to have a database, we're going to have a work group, we're going to have a database, and then we're not doing the named query yet, or the prepared statement, work group and database. So we have everything that we can have. Let's just see, because the other things seem like they're nice to haves. So let's just see if we can, what does plan do? Does it even allow us to do this? We haven't set up any perms or anything for it. Okay, well, let's see. Athena database, raw metrics working group. Let's just give it a go. Let's just give it a go. A giggity go go. Yeah, let's go. Okay, let's go back to, not that. Must be this one, okay. Let's go back here. Let's launch the query editor. We now have a raw metric events. Workgroup raw metric events setting. All queries run in the workgroup raw metric events will use the following settings. Query result location. No idea what the heck that is. It's empty. All right, well, yeah, it's empty. I acknowledge this. Okay. Okay, no tables. Okay, but now ChatGPT. ChatGPT's saying we need to run a query to do this ourselves. Yeah, we can copy this. And we're not going to want to put this here. See, this is where things get a little weird. Let's just put something here for right now. We're not going to want to leave this here though, because we're going to want to call this create raw metric events table. The database we're going to have, and so this needs to be the database name. So this is going to be the AWS Athena database dot, is that not what it's called? Yeah, it's right here. Dot raw metric events Athena DB dot name. But now what did I call it? Metric event stream raw events. Okay, now this is the part that's weird to me about all of this. This is fine and all. This is fine and all, but this is duplicative. And this is not likely where we're going to want to keep this. Because this is duplicative of the wrapper. So for this module, we create this glue database table outside of this, which formally defines this schema already. So the question is, can I define an Athena table in terms of an AWS Athena table in terms of an AWS glue catalog table? Can define an AWS Athena table in terms of a glue catalog table to avoid duplicating the columns and types. AWS glue catalog is a fully managed Hive-compatible metadata repository that AWS Athena uses to store information. By defining your table schema in the AWS glue catalog, you enable Athena to query data using this shared metadata repository, which means you don't have to manually define the table schema in Athena again. Here's how you can set up an AWS glue catalog table for Parquet files in S3, which can then be queried by Athena without directly defining the table's schema in Athena. Create an S3 bucket for Parquet files. We first ensure Parquet files are stored in the S3 bucket with the appropriate permissions. We already do that, maybe not the appropriate permissions for Athena to access, so we might have to fix that. But define an IAM role for AWS Glue. Create an IAM role that Glue can assume to access your S3 data. We already did. Support an AWS Glue catalog. Set up an AWS Glue catalog database. We have one. Set up table. Use Terraform to define an AWS Glue catalog table resource. This table points to your S3 Parquet files and includes the schema that matches. Does it point to the S3? That is the question. Right now it doesn't. Replace placeholders. Your bucket name, data, column, blah, with actual S3 bucket path. See, all we describe in the storage description is this. We don't specify the question is if we do specify, question is if we do specify, we'd also need this Saturday information. All right, I'll be right back, chat. right, back. The weird thing about this, now is that before, well, this is sitting outside of the module, the Terraform module. And before, it was simply acting as a mechanism of providing the schema that Firehose was using to store the raw metric events. Okay, so this effectively allowed consumers of the module to change and configure what the schema of their raw events should be, right? However, adding information like this outside of the module is conflicting in my mind, because inside the module is where we have this information inside of the Firehose configuration. And that's what feels wrong about this. Like, on one hand, we have this, which feels wrong because this is defining and using the glue catalog table supposedly to reference an S3 bucket, which can supposedly be used with Athena. However, on the other end of the spectrum, we have the other use case, which is Firehose, which is storing the things, which needs to know what format to store the things in. And that is inside of our module here. If we ignore that, so we have this AWS Kinesis Firehose delivery stream. Now this defines the partitioning. This also defines the output format to be Parquet file. And then it has a schema configuration for the table. And this is where we reference that glue catalog database and name that are passed in. But we also are using the S3 bucket that we've created here. So there's this weird separation or lack of separation that's occurring here that we need to figure out. And it's ideally we want the configuration outside of the module of what the schema looks like. That makes sense with this glue catalog database being used for this. However, then we have to figure out how we let Athena know what the schema should look like. And for whatever reason, Athena doesn't seem to align with that. We can duplicate the schema by creating an Athena table creating a named query in Athena that can then create the table inside of Athena for us. That is one option. That has the downside of duplicating the columns. And then we have this other option, theoretically, of using a glue catalog table, because glue catalog tables are supported. But if we use a glue catalog table, somehow we have to tell that glue catalog table, which already, if we use the one we already have, it already knows the columns and the types. It, however, does not know the partitioning, and it does not know the S3 bucket. So we'd have to somehow tell it the S3 bucket and somehow tell it the partitioning. So, which I don't even know if is possible. I mean, ChatGPT said, what did they do? So ChatGPT creates an external table, parameters, parquet, compression, none, name, database name, gives it some Faraday parquet hive file format, the S3 bucket, the input format, the output format, the columns. And then does set up partition keys. So it looks like if ChatGPT is right, we can specify the partition keys. Okay, but if we do this here, now all of a sudden this has to have knowledge of the S3 bucket. And we've duplicated our partition keys. Unless is prefix extended S3 configuration. Unless the schema configuration. So this becomes a new question. Let's ask ChatGPT. What are we going to ask? Will AWS Stream use the partitioning information in the associated AWS Glue catalog table if no prefix is defined for the extended S3 configuration. Option to configure to use a prefix for S3 bucket location where the data is stored. This is particularly useful for organizing your data into folder structure that represents different partitions or categories, making it easy to manage and query the data later, especially with services like Amazon. Yes, that's what I'm trying to do. However, when it comes to AWS Glue, which is a managed ETL, data catalog service, the integration between Kinesis Firehose and AWS Glue is more about the metadata and schema for the streamed data rather than direct partition management on the S3 side of through Firehose. AWS Glue can catalog your data in S3, understand its schema, and offer transformations, but the direct partitioning within S3 via Kinesis Firehose configuration is a separate concern. If no prefix is defined in the Kinesis Firehose extended S3 destination configured, Kinesis Firehose does not automatically use partitioning information from the associated AWS Glue catalog table for organizing data. The reason is that Firehose delivery stream's primary role is to efficiently and reliably stream data into the destination like S3, and while it can be configured to use prefixes, including dynamic ones based on timestamps or incoming data attributes, it doesn't inherently understand or interact with Glue's catalog structure or partitioning. To achieve a partitioning scheme that aligns with your AWS Glue catalog, you would typically manually specify a prefix pattern in the Kinesis S3 destination setting that matches your intended partition structure. Use AWS Glue or another ETL process to organize or reorganize the data into the desired partition structure after it has been delivered to S3. This approach allows for the separation of concerns between data ingestion, handled by the Kinesis firehose, and data organization management. For dynamically partitioning data based on the content or timestamps directly within the streaming process, consider implementing preprocessor step. Okay. So it's sounding like it doesn't do what I was hoping it does. And they're saying basically define both. And what that means, and I was thinking about this some more, is maybe we should allow these prefixes to be configured externally. That way, they at least are aware. The consumer of the module is at least aware and able to control and configure these, the partitioning and the prefix in general. So maybe that is the appropriate next step. All right, cool. It's getting late. I gotta go eat. I will catch y'all tomorrow sometime.